In this video, we're going to learn on how to sketch the graph for a linear function, and later we find out the corresponding domain and range in general. So, a linear functions, we have the form in our case here, fx equals to mx plus c, where m is corresponding to a real number that is not equal to 0, c is a real number, and in here, basically to sketch the graph of a linear function is just as simple as we draw a straight line joining any 2 points from the functions. And in general, the domain and range is all real number in this case here. And next, let us see how to sketch the graph for linear functions. In here we have 3 examples. Let us begin with the first one. Let's say I have the function fx equals to 2x minus 1, a linear functions. To sketch the graph here, what we will do is that let us find out 2 points from these functions and then we join with a straight line. So let's say I construct a simple table and find out the 2 points by using when x equals to 0, substitute into the function, then the corresponding y value or the value of fx I find out is -1. And this point here, the combination of 0 for x and -1 for y is actually correspond to the y-intercept. Then next, we use y equal to 0, substitute y equals to 0 into the function. I find out that I have x equals to 1 over 2. And the combinations of these two values here will give us the x-intercept. By referring to these 2 points here, we join them with a straight line. We have the graph of this linear function fx equals to 2x. The next examples, basically we're just going to repeat the same process. Let's say I have fx equals to minus x plus 2. So what am I going to do here? Again, I'm going to find 2 points from the functions and then join them with a straight line. And you find out that usually we will try to make use of the y and x intercept for the 2 points. And to get the y-intercept, I'm going to have calculated by calculation by x equal to 0. Find out the y value, again, which is the fx value in this case here. I find out that it's equals to positive 2. So from here, 0 to the combinations here, it gives me the y-intercept. Then next, I consider when y equal to 0, which means that the fx here, if let's say equal to 0, the corresponding x value that I have, I find out that it's equal to 2. The combinations of these two xy value, it will give me the x-intercept. Now I have the 2 points, the x and y-intercept. I combine them, I join them with a straight line. There goes the linear function graph for the case of fx here. Then lastly, let's say I have the example number 3 like this form here. Fx equals to 3 over 2x. So how are we going to do? So these examples here, if you want to use the same way, you will see there is slight different changes that we need to make. Where first, you find out that when the time you consider the calculation, you let x equals to 0, you try to find out what is the y-intercept, you find out that the result is also 0 when the time you substitute in here to calculate the y value. You find out that I have the combinations of the x0, y0, which is the origin. And you find out that in this case here, the x and y-intercept is happened on the same point. It's no longer like just now x and y-intercept is 2 different points. We can join with a straight line to get the graph. In this case here, what we're going to do is that we're going to find one more point which is outside of x and y axis, but yet still inside this function here. For example, if let's say I consider x equals to 4, I substitute 4 inside to this function here. I find out the value of y is equals to 6. And for 6 here, according to the diagram, it will be this point here. Now with the reference of these 2 points, I join with a straight line. I have done the graph. But take notes, since this point here, 4, 6 is not the point, not the important point that we should show in the graph, so we must erase it once we have done the graph sketching. And there goes this answer here for our example 3. Then now, for each of the example, let us try to see what is the domain and range. And you happen to find out in example 1, the domain of this graph here is actually infinity to infinity, as it covers every single x value from the Cartesian plane, as you can see. For range, it covers every single y value. Similarly, for example 2 and 3, the domain and range is happen to be all real number. So that's all for this video here about linear function for the graph and also its domain and range.